Hello everyone. In today's topic, we are going to talk about Unit 2, real numbers, specifically about rational numbers. So first, we are going to have the history of real numbers, a short one. So the Hindu-Arabic system used the numbers from 1 to 9. Zero was only added when it was discovered by an Indian mathematician. By the 17th century, René Descartes introduced the real numbers and distinguished the differences from imaginary numbers. So first, we are going to study about real number system. So real number system composed of rational numbers and irrational numbers. Rational numbers compose of natural numbers. When we say natural numbers, they are the counting numbers, which starts from 1. So we have 1, 2, 3, 4, 5, 6, and so on and so forth. And then if 0 is added to natural numbers, we call it whole numbers. So whole numbers starts from 0, 1, 2, 3, 4, 5, 6, and so on and so forth. And when negative numbers are added to 0 plus the natural numbers, we call it integers. So integers compose of 0, the negative numbers, and the positive numbers. And if we are going to include all the fractions, including the positive, the 0, and the negative, we call it rational numbers. So rational numbers are natural numbers, whole numbers, integers, and all other numbers aside from integers, which can be expressed as fractions. And then those other numbers that are not rational anymore, we call it irrational numbers, which we will discuss in the next lesson. So let us discuss rational numbers. A rational number is a number which can be expressed as a fraction, a over b, when a and b are any integers and b is not equal to 0. So examples for this one, we have 3/4 is equal to 0.75, and we call it terminating decimal because the decimal ends. So we only have 7 and 5 as the digits after the decimal point. So it ends. And we have repeating decimals, which are 1 over 3, 11 over 37. So as you can see here, 1/3 is equal to 0.333 So therefore, the digit 3 is repeating continuously. As well as in 11 over 37, 0.297. So these digits are repeating continuously. So therefore, they are repeating decimals. It means that the decimals never end and one or more digits are repeated continuously. Now let us write fractions as decimals. So our first example will be 2 over 3. So 2 as the numerator and 3 as the denominator. From here, we are going to divide 2 divided by 3. And the result is 0.666 meaning 6 is being repeated continuously. So instead of us writing 0.666 we will simply write 0.6 and a dot at the top of 6, meaning 6 is repeated continuously. So 2 over 3 is equal to 0.6 and a dot at the top of 6. Now let us have another one. So we have 35 over 14. In here, we all know that 35 and 14 is divisible by 7. So from here, 35 divided by 7 is equal to 5 and 14 divided by 7 is equal to 2. So from here, it will be easy for us to divide. So 5 divided by 2 is equal to 1 or 2.5, I should say. So 2.5 is a terminating decimal. So in here, 35 over 14 is equal to 2.5. Now let us have another example, 15 over 37. So since there is no number that can divide 15 and 37, we simply divide 15 divided by 37, which is equal to 0.405405. As you can see here, the digits 40 and 5 are repeated continuously. So instead of us writing these numbers, we can simply write 0.405, and we are going to place that at the top of these digits, meaning the digits 405 are repeated continuously. Now let us have another one. The last example, underwriting fractions as decimals. So if we have negative 11 over 24, so we are going to divide 11 divided by 24, which is equal to 0.45833, and so on and so forth. In here, we observe that 3 is being repeated continuously. So what we need to do here, instead of us writing the whole of this one, so negative 11 over 24 is equal to, so it is negative, so negative 0.4583, and put that at the top of 3. Now let's move on to writing repeating decimals to fractions. So this time we are going to write repeating decimals to fractions. So these are the rules for writing repeating decimals or fractions. On the numerator, the numbers after the decimal point is subtracted to a non-dotted number. In case all numbers are dotted, then it is automatically subtracted to 0. On the denominator, only numbers 0 and 9 are used. The numbers of nines means the number of the repeating digits. The numbers of zeros means the number of non-repeating digits. In case there is none of the non-repeating digit, there's no need to put 0 anymore. So let us have this one. So let us rewrite 0.3333, meaning 3 is repeated continuously, to fraction. So the first thing we need to do here is to copy the digits after your decimal number. So we only have 3. Minus the non-dotted number, so we don't have any, so minus 0, over, we only have 1, the number of repeating digit, we only have 1 repeating digit, which is 3, so we have only 1 9. So from here, 3 minus 0 is 3, so we have 3 over 9, and it's divisible by 3, simplifying further to its lowest term. So the answer is 1 over 3, or 1/3. So 0.3 with that at the top is equal to 1/3. Now let us have example number 2. 0.52 with a dot at 2, at the top of 2, meaning 2 is repeated continuously. So from here, to rewrite this one to fraction, we are going to copy all the digits after the decimal point, minus the non-dotted number 5. From here, it is non-dotted. And then how many 9 do we need to write? We only have 1 repeating digit, I should say. And then we also have non-repeating digit. So we represent it as 0. So 1 9, 1 repeating digit, and 1 non-repeating digit, which is 5. So from here, 52 minus 5 is equal to 47 over 90. Since there is no number that can divide both, to simplify this fraction, this is the final answer. So 0.52 with that at the top of 2, it is equal to 47 over 90. Now let us have example number 3, 0.4848, meaning the digits 4 and 8 are repeated continuously. So in doing this, the first step, we are going to copy the digits after the decimal point. So we have 48 minus the non-dotted one, we don't have any, so minus 0, over, we have 2 repeating decimals, so we have 2 9s in here, And we don't have non-repeating decimals, so we need not to write 0. So 48 over 99, it is divisible, these numbers are divisible by 3. So simplifying further to its lowest term, so 48 divided by 3 is 16, 99 divided by 3 is 33. So we have 16 over 33. Now let us have example number 4. So in here, we have 0.23627. So meaning the digits 6 to 7 are repeated continuously. So from here, we are going to copy all the digits after the decimal point minus the non-dotted number. So we have 23 minus 23 over how many nines do we have? 3, because we have 3 repeating numbers. So 6 to 7. So we have 3. And then we also have non-repeating numbers. We have 2 and 3. So 2 zeros over there. So this is the repeating digits. So we have 1, 2, 3. So we have 3, 9. And we have 2 zeros here because we have 2 non-repeating digits. So from here, 23,627 minus 23 is equal to 23,604 over 99,900. So dividing both the numerator and the denominator by 12. So the final answer for this one, 0.23627, 627, or simply 0.23627 with dots at the top of 627, it is equal to 1,967 over 8,325. So that's it for now. Thank you for watching. Please do your exercise 2A in page 25. See you again next time. Bye.